Alrighty, welcome everyone to day 5 of Advent to Code 2019. Today, the problem is going to expand upon our int code program we wrote on day 2. So I've gone ahead already and copied over the code that we had on day 2 and removed all the noun verb stuff. So we just have the interpreter that we programmed last time. So for today's problem, we are, like I said, we are expanding upon this and adding 2 more opcodes. Opcode 3 is an input opcode. We take in an input and put it into the address as specified by the parameter. Opcode 4 is the exact opposite in that we're outputting what is at the address specified at the parameter. In addition to the 2 opcodes, we also have to add support for what they call parameter modes. This is pretty standard in any assembly-like language. You will have a way to reference an address and a way to just reference a number itself. They're calling these position mode, which we have already currently implemented, which is taking the location and using it as a position to get the value at that position. And then immediate mode, which is instead of doing this, we interpret what is there as a number itself. So in order to do that, they expand upon what the opcodes are. So for opcodes, there are 5 positions or 5 digits. From right to left, going backwards, the first 2 digits are the opcode. So 01, 02, 03, 04, 99, so on. The next digit from right to left, so the third digit, the middle one, is the mode of the first parameter. The next digit is the mode of the second, and the last is the mode of the third parameter. If there's a leading 0, it's just omitted. So, knowing that, let's start off by adding in the 2 new opcodes. So opcode 3 is an input, opcode 4 is an output. So in our code here, we currently deal with this by just adding another case. For a case of 3, we will be taking input and storing it. So let's do first, I'm not going to deal with the modes yet. We'll treat this as everything is still in position mode, and we'll go from there. So location for the inputs will be here. And then what we will be doing is inputs, we need a scanner real quick. That way we can get inputs into our system. And down here, after we do all this, close the scanner. And this will be equal to scanner.next int. All good there. And then from there, we will be simply setting the program list at location equal to our inputs. Nothing else. I could actually condense this down to 1 line, but for now I'm not going to because there's not a huge point in it. Break, and then don't forget to increment our program counter by 2. Because there's only 1 parameter, so we skip over the opcode and skip over the parameter, and that's and that is where our program counter will now reside. So now that's done, let's go ahead and do the next opcode, which is case 4. Again, this will take in a location, but instead of saving anything, all that will be done. Of course, we can't have location. Okay, fine. Because I forgot we can't have location like that. We will actually just simplify it. So I'll go system out print line and simply output wherever we are told to go to. And yeah, that's honestly all there is. That will suffice for the 2 opcodes. We read in inputs, store it wherever it tells us, and then output whatever it tells us to output. So now the next bit is to handle mode switching from position to immediate mode. The biggest thing that this will affect is this whole opcode here. So program list at PC, this will give us an integer. However, we need to parse this. So what we'll actually be doing is doing string. This is instruction equal to this. So for this instruction, so the last 2 digits will become our opcode. We'll be doing integer parse int, and what we will do is do instruction substring from instruction.length -2. That will include the last 2 digits. And then we should be good on our opcodes. Okay. So now the next bit is to handle all the switching between position mode and intermediate mode. So what I'm gonna do here is I'm going to prepend spaces. So I'm going to force this instruction string to be 6 characters long. So for int I equals instruction dot length while I is less than 5, I plus plus, and we will go ahead and do instruction equals space, or instruction equals 0 plus that. That way now we are prepending on a 0 in front of the instruction, just so that we don't have any error issues with missing leading zeros and all that. So now we need to know which mode each of the parameters are in and deal with them accordingly. So let's just do booleans. Param1 pause mode, let's just call it like this, and it'll simply be instruction char at 3 and equals 0, anything else, and it is not in position mode. And these, actually this is 2, not 3, 2, 1, and 0, param1 and parameter 3. So there you go. So now we have what modes each of our instructions is in. So now to handle this, instead of treating it like this, we need to know what we need. How do I want to handle this? So we have result is the addition of what's at each location. So this bit needs to be adjusted. So we always need this. So this is parameter 1. And okay. So we are going to do an int array. This is going to be our params. I'm just gonna set it equal to 3. Honestly, you would be very well able to get away with just doing 3 variables here. I don't want to do 3 variables, and actually I'm going to convert this to not be 3 variables just because I don't want to expand. The expansion of this is going to be really much harder to do. So I'm going to go ahead and do this. Oh, this goes out here, sorry. Our parameters, and then our parameter modes. My bad. So the reason why I'm doing it this way is because this makes it a little bit more expandable. Instead of having just to keep adding variables and adding variables, this will be a little better. Not much, but a little better. So there's parameter 1, 2, and 3. Okay, and then our parameters are here. So params 0 will be equal to that. And go ahead and set parameter 1 here equal to this. Okay. And then lastly, parameter 2, 3. So the only bit here is we just needed to test this relevant bits here. So this actually becomes that. Okay. So we need to check if our parameter modes, if parameter mode of 0, then we are in. Okay, I think I got a little ahead of myself. These parameters are not quite this. So if our parameter mode is 0, this means it will be in position mode. So parameter 0 is actually this and not what I had up here. Otherwise, if the parameter mode is not in position mode, that means it's in intermediate mode. Parameter 0 is actually just what is here. There we go. And then result is parameter 0 plus what will be parameter 1. And we will deal, whoops, with the next one, just like we did first. So parameter of 1, 1, increment by 2, increment by 2, and do 1 there. And now we should be good there. For this one, parameter 2 will always be in position mode. We should be also checking this one too. Again, this isn't necessary, but we will do it anyways. All right, there we go. All right, so we have this, we'll do this every time, so we can actually condense this down to a method here. Let me take all of this, move it into a new method, public day 5, put it all in there, so we call it new day 5. This way we're out of a static method. We don't need to deal with the whole static method stuff. Okay, so now we can make a new method, public void compute get value for mode, for param mode, and we are going to be taking this. We will be returning that, So all we need to know is the mode, or we just need to know Boolean, Boolean position mode. I can spell Boolean, right? That'd be helpful. Boolean position mode, and this goes here. And we then just need the program list. Let's call it the program. And then our program counter, which will include the +1s already in it. There we go. And this, of course, will return an integer. Forgot about that. All right, so move this up here. Case 1. Params 0 simply updates for program lists. So pass that through, pass the program list through, and pass in PC +1 through. Oh, it's an integer. Sorry. This is an integer. Right. In theory, you could even go further with this. If you're better keeping track of the program counter, you would need to pass the program counter through as well as the program list. But for now, we will be It's just how it is. But if you were doing this a little bit more improved, that way the program and the program counter were global in this class, you wouldn't need to pass those through. But either way, okay. So now we can condense this all down. And we don't need, there we go. And now we don't need all of this. So now we have results, and all of this is correct. Okay, for this one, actually, we will always be doing this. So this one actually isn't, we don't need to get the param. So, okay. There we go, and this will actually just copy straight over to the multiplication because it'll be identical. Except this will be now multiplication, and then this will be parameter 2, and good. All right. This one will be basically the same, param 0, and can this be in? Yeah, so you can't have immediate mode for 4. So this one actually will be just like this. You can't have immediate mode for it. So we don't really gain anything by doing it this way on here, but either way. But the output can be either or, I would assume. Okay, yeah, I believe then this is going to stay as it is. So these params are more of meant for the other stuff, but just so we're kind of keeping things uniform and whatnot, I'll do it for the rest of them. All right, so let me go ahead and put an output here. This is going to be enter or give input to print. Okay, and we should be good. So let's actually try and run this. I'm curious. Give us a run. All right, so our input provide 1, and we're infinitely outputting 0. Okay. Okay, I believe I'm actually wrong in what I thought here. This actually does need to be this. I believe I was wrong. That does need to be that because this will give me either, yeah, because it needs to be, they're all immediates. So that does need that. And this can PC plus 3. Yeah, so these all can just use it. We shouldn't be not using it, I guess. Okay. Okay, let's give that a shot. That might have been our issue. Oh, I'm still outputting something I don't want. Oh, no, I'm good. Okay. Very next out of bounds exception. Okay. Making progress. Okay. All right. I was wrong. But I said before, this is always equal to that. Because of the parameter mode, it doesn't work. This is returning. Right. So this is always right, because this is setting. Okay. So give input, this is PC plus 1. And this one is correct. Okay. Let's try that instead. Let's remove my logging stuff real quick. I used the debug. Okay. Let's give this a shot. That works. Okay. And put this as our answer. And it's right. All right. Not bad. So the issue, for those who don't know, was the fact that this get value for param mode returns the value that we want. However, parameter 2 for these, we are setting the value. Because we are setting the value, let's go to the example for this here. So this is add this number, or what's here and what's here, and set the 6th memory address, which is right here, set that to our result. Because of that, we want to store that. We don't want to evaluate that. So this is technically position mode. However, we don't want to grab what's here. We want to store that to then set what's here. It's a little hard for me to explain-ish, or explain good, but just know that because this works differently, we don't want to get the value. We want to set the value for the param mode. Either way. All right, so there's that. So they're on to part 2. Let me read part 2 and we'll get back to you guys. Okay, so part 2 is actually just adding more opcodes. Yay, so we're making our interpreter here even larger. This switch table will probably get pretty big, but it's still manageable for now. So our opcodes. Opcode 5 is jump if true. So if the first parameter is non-zero, it sets the instruction pointer to the value from the second parameter, otherwise it does nothing. Basically, if you don't know assembly, this is how if statements work in assembly, or when they're compiled down. The if statements basically are interpreted. Opcode 6 is jump if false, just the opposite of jump if true. So if the first parameter is 0, then we set our instruction pointer to the value of the second parameter. I'll explain these more in a second here. Opcode 7 is a less than. If the first parameter is less than the second parameter, it stores a 1 in the position given by the third parameter, otherwise it stores 0. And opcode 8 is equals. If the first parameter is equal to the second parameter, it stores a 1 in the position given by the third parameter, otherwise it stores 0. So just to explain what these are doing, the opcodes 7 and 8 are our basic arithmetic Boolean logic stuff. Opcode 7 compares if one number is less than the other. Opcode 8 compares if they're equal. And whether or not they're equal or not, it stores a 1 or a 0 depending upon that Boolean logic. That can then be used in conjunction with our jumps to do a condition. And if, say, less than is true, we can then jump to a different part of code. We can add branching now to our code. Before this, our code was all linear logically, couldn't do anything else besides just run linearly. Now that we have jumps, we can add in branching, which allow us to branch different parts of code depending upon logical comparisons. So let's start with the first one, case 5, which is our jump if true. So the first parameter is non-zero, so we have 2 parameters. We want to get both of these, or we want to get the first one. The second one we would like to hold. So param2 will be a set parameter, so we will just hold what's there. This is pretty straightforward. If parameter 0 equals 0, or wait, if it's non-zero, if parameter 0 is not 0, we will be setting the instruction counter, which I'm calling the program counter, to be equal to the position stored by parameter 1 here. So we'll be doing PC equals parameter 1. Actually, we'll do it this way. And then otherwise, we just saw increment program counter to jump over this. It does nothing. Yeah, so it does nothing. And by doing nothing, we have to increment program counter by 3 to jump over this code logic. All right, and then likewise, the next opcode 6, the jump if false, will be basically identical, except If it's equal to 0, we jump, otherwise we don't. And there we go. All right, so now opcode 7 here. This one is the less than. So if the first parameter is less than the second parameter, so we will need to get the values for the first two. So, whoops, so parameter 0, parameter 1, 1, and then 2. Okay, so we will be then storing what's in the third. So parameter 2 equals that. And let me see, yes, okay. So we will be storing in here the result of parameter, the first parameter is less than the second parameter. I will be doing this is just a ternary operator. We will be storing a 1. Yep, and then store a 0. If you don't know, this is a ternary operator. If this evaluates to true, we do whatever this bit says. Otherwise, we do what this bit says. So in this case, this is equal to 1 or 0, depending upon if this is true or not. Cool. And then case 7 and case 8. Whoops. Before I do that, let's not forget to increment our program counter by 4. Yes. And for the last opcode here for 8, this is equals. This instead is just equals. Everything is identical. All right, so let's go ahead and run this and see what happens. So this time we want to put in 5 as our ID, and we get an out of bounds exception here for 7. Okay, so 7, first parameter is less than the second parameter. It stores a 1. Okay, so somehow this is incorrect. Oh, you know what would be helpful to have? Breaks. Those might be helpful to put in here. It might be helpful to add break statements. All right, is this gonna be? Okay, yeah. Oops, my bad. I just forgot to do breaks. Okay. Reset this to the actual program. Run this again. ID of 5. And we get nothing as an output. Okay, maybe we do need to test more stuff. Oh, wait, we're not, my bad. I need to actually solve that. Whoops. These need to actually be accounted for. They need to be actually, we're getting the value, so we need to account for which mode we're in. So let me remove this debug output here. Restart this. So now if we put in 0, we should get 0 back. Okay. Now let's try again with our long input. Give it 5. And now we get index out of bounds exception from here. Interesting. Because these need to be changed to 0 and 1. Hey, there we go. Now we got an output. Submit it. Correct. Nice. All right. Again, today's wasn't too hard. This, if you are someone newer to programming and you're not going through college yet, you are. This is a very good program for you to learn. I'm actually in a class right now where we actually wrote an interpreter parser for a made-up language like this. So this is very much a worthwhile problem to learn and to figure out. Obviously, this isn't the most expandable thing in the world. There is a much better ways to do this. But for the scale of this isn't this works well enough. But you can definitely get into much better practices with doing this kind of in better ways. But aside from that, to wrap up today and explain what we did. So today we actually added how many? 1, 2, 3, 4, 5, 6 new opcodes to our int code program. The first opcode took an input in and saved it. The next opcode then outputted a output based upon the address given. We added 2 jumps, one for jump if true, another for jump if false. That allowed us to add branching into our programs. And then we had 2 more opcodes for conditions that would set memory based upon a condition. We had an equals and then a less than opcode. So this is actually becoming like a full-on programming language that we're building an interpreter for here, which is pretty cool. I'm really enjoying it. But yeah, and then the last thing we also did was we added in parameter mode, which is intermediate versus positions. Again, if you ever worked with assembly, this is straight up assembly here, having intermediates versus memory addresses and pointers and that stuff. So anyways, hopefully you guys enjoyed today, and I will see you guys all tomorrow. Peace out.